Okay, the Jefferson method requires an extra step, but the process is very similar. So our quotas, let's just go back and get our quotas right here. Let's just copy this, paste it down here. So consider the Jefferson method like a race that you're running, okay? So what you do is you do this intermediate step where suppose you round all of them up. Suppose, okay, softs have 10.31. Suppose you gave them the 11th. Juniors have 5.33. Suppose you gave them the 6th. And then seniors have 4.36. Suppose you gave them the 5th. Suppose you round all of them up. It's a hypothetical. Who would do the most benefit with that extra seat? So what you do is you round all the quotas up. Okay, so you do sophomores, and that's what this says right here, the truncated quota plus 1. That just means round them all up. Okay, this is not the final answer. This is just the intermediate step. So if you were to round all of them up, so softs have 464 students. Suppose you gave them the 11th seat. Right? Let's break out Desmos here. Little split screen action here. Okay, so softs have 464. Suppose you gave them the 11th seat. Well, that you get a result of 42.18. That means that if you gave the sophomores the 11th seat, they would represent 42.18 students with it. Okay. Juniors have 240. Suppose you gave them 5.33. Suppose you gave them the extra seat. Suppose you gave them the 6th seat. Well, 240 divided by 6 is just 40. So do you see how sophomores would do more benefit? They'd do a greater benefit with the extra seat because they would represent more students. They would represent 42 students, whereas the juniors with an extra seat would only represent 40. Okay, so that's the greater service. So the Jefferson method says give it to the class, give that extra seat to the class who does the greater service with it. So seniors have 196. Suppose we round their quota up. So 4.36 is their quota. Suppose we gave them a 5th seat. So 196 divided by 5, it's only 39.2. So clearly, the sophomores would do the greatest benefit if you gave them the extra seat. So these are called the Jefferson ratios that you're finding. These are not the final answers. You're just using these ratios to declare a final winner. So the highest Jefferson ratio of all is the sophomores. Highest ratio is sophomores. So you round their quota up. You don't round these up. The 42 does not round up. The 40, the 39, you're not rounding those. Those are just hypothetical ratios used to determine who should get the seat. So you go back to the quotas. So the sophomores have 10.31. We're going to round them up to 11. Because we already determined that they have the highest ratio. So the 42.18 is higher than the others. So that means we're going to take their quota and round it up. We're giving them the extra seat. The juniors have 5.33. We're rounding them down. And then the seniors have 4.36. We're rounding them down as well. You're rounding up the class that has the highest Jefferson ratio and rounding down the others. Now this is a different answer than we got before, right? So final apportionment is 11, 5, and 4. in the Hamilton method that we did in the previous video, we got an answer of 10, 5, and 5. Both add up to 20, right? So we know that all of our seats are accounted for. But this is your final answer. And that's okay. If the two methods give you different results, that's okay. That's why there's two different methods, because sometimes you get different answers based on who needs the seat more. All right, so that's the Jefferson method. That'll be it for this video. You could try these examples down here. I'll do probably one more video with, I'll do one of these examples, do both methods out in one video. All right.